Hey, this is Mrs. Kreider, and today's bell work is a little more practice on your special right triangles. So we're going to go ahead and run through them. Hopefully you've had a chance to work through them yourselves, but these are a little trickier. You'll notice that the question number 1 is easily recognizable as a 45, 45, 90 because we have those 45-degree angles marked, and we of course have our 90-degree angle. Now this one's a little trickier because we have our hypotenuse. We're used to seeing that with a square root of 2, and this one doesn't have a square root of 2. So we're going to have to come across this a different way using that pattern. So what we want to do is, if the hypotenuse is known, we know that the leg times the square root of 2 equals the hypotenuse. But what if we want the value of the leg and we know the hypotenuse? Using just some basic algebra, we can divide by the square root of 2, and there's our answer. Those cancel, and the leg equals the hypotenuse divided by the square root of 2. The problem is we can't actually leave it like that. We have to rationalize it. Now, rationalizing is something that you may or may not have seen yet this year, and it just means that we can't have a radical symbol in the denominator of a fraction. So we have to multiply by that number above itself as a fraction to get rid of it. It's real easy. We're just going to show a little example. The leg equals the hypotenuse divided by the square root of 2 times, and it's always going to be that square root of 2, or that, whatever the radical is, made into a fraction that is equal to 1. So, and this is a terrible 2, and I apologize for that. But when we multiply this out, this is going to be the hypotenuse times the square root of 2 divided by 2. And that's 2 because the square root of 2 times the square root of 2 equals the square root of 4, and the square root of 4 is just 2. So we can rewrite this in a more simple fashion as the hypotenuse divided by 2 times the square root of 2 is the leg. So that is just a shortcut way to approach a 45, 45, 90 triangle when you know the hypotenuse. You're just going to cut the hypotenuse in half and multiply it times the square root of 2. So since our hypotenuse is 14, we are going to multiply, or the leg is going to be equal to 14 over 2 times the square root of 2. Okay, so that's a 14. 14 over 2 is 7. So it's 7 times the square root of 2. And the leg is x. So x equals 7 times the square root of 2. Okay, let's really quickly go over the next one. We can recognize this is a 30, 60, 90 triangle. Those are the measures of our 3 angles. And if you'll remember, the short side is always across from the 30-degree angle, and the short side is always half of the hypotenuse. And remember, that comes from the fact that this is half of an equilateral triangle. So this would have been 28, and this whole thing would have been 28. So we cut that in half, and we know that x equals 14. Easy peasy. X equals 14. And then all we have to do to get y is 14 times the square root of 3. Okay, check back to your notes. The rule on that is that the short leg equals the hypotenuse over 2, and the long leg equals the short leg times the square root of 3. Okay, that's it for the bell work. Let's go ahead and jump right into our topic today, which is trigonometric ratios. We're going to start trigonometric ratios with the basic idea that triangles that are similar drive trigonometry. Trigonometry is literally the measurement, okay, that's what metry means, okay, the measurement of a trigon, which is a triangle. A polygon is a multiple-sided closed figure. A trigon is a closed figure with 3 sides, because tri means 3. So we're just measuring triangles. That's all it means. Now, we can look at the 2 triangles that are noted here, and we can see that 3 and 6, they're double. 6 is 2 times 3. 4 and 8, that's also a double. And 5 and 10 is a double. So right away, we could use side, side, side similarity to establish that these triangles are similar. And what we could do normally is we would put, fractions together, our ratios. 3 over 6 is a 1/2 ratio. 3 over 6, okay, is equal to the same ratio as 4 over 8, okay, which is equal to the same ratio as 5 over 10. That's how we check for side similarity. We put them all into ratios, and then we establish that they boil down to the same reduced fraction, which is 1/2. So these are similar triangles with a scale factor of 1/2. Now, what I want to show you next, though, is, and I'm going to actually erase all of this so I can show you a different way of looking at this. What if instead of comparing side to side between the two triangles, we just looked at what happened when we compared sides within one triangle? So for kicks, let's just say that we are going to use angle B as our reference angle. Okay, so I'm just going to make a nice dot at angle B. So everything we talk about is going to be from the perspective of angle B. And I don't know why my little dot is deciding to disappear. That is just incredibly spooky. Okay, there we go. So reference angle B. Now, I can identify that the 5 is the hypotenuse. And we know this because the hypotenuse is always the longest side of a triangle when it's a right triangle. And it's always across from that 90-degree angle. So that's going to be our hypotenuse. I always identify that one first when I'm working in trigonometry. And then I have two others that I can choose from. One side is going to be opposite to angle B, and the other side is going to be adjacent to angle B. Now, adjacent is like when you have a duplex and they share a wall. That wall makes them adjacent. So it literally means right next to. So if I have to travel across the triangle to get to my side, then that side is an opposite side. So 3 is the side length of the side that is opposite to angle B. And that leaves 4 to be the side that is adjacent to angle B. And to be honest with you, that's exactly how I work through these. I always look at my reference angle, and I decide first which is the hypotenuse, and then I figure out which is the opposite because I know I have to travel across the triangle to get there. And then the only one remaining is always going to be adjacent. That seems to be the one that everybody struggles with. So if I looked at the length of the, let's say, the opposite side over the hypotenuse, okay, so if I looked at the opposite divided by the hypotenuse, then I would get the ratio of 3/5, or the fraction 3/5. Now, let's go over here and pretend that we are angle E for a second. Now, we know that since these triangles are similar, angle B and angle E are congruent. Okay, so that means that no matter what the size of the triangle, if they're similar, the angles are congruent. And we're going to go through the same process of identifying that this is the hypotenuse, okay, this is the opposite, and this is the adjacent. Now, if I were looking at angle E, and I wanted to know the length of the opposite side divided by the hypotenuse for this triangle, it would be 6, because 6 is across, that's the opposite, divided by 10. And what's cool about that is if you reduce that fraction, it reduces to 3/5. So what happens is you notice that this fraction for the smaller triangle is exactly the same as the fraction for the bigger triangle. We knew the triangles were similar, and now we know that when we compare specific sides into ratios, those ratios are going to be identical when we know the triangles are similar. So that's what trigonometry is based on. It's based on right triangles that are similar. So when the angles are the same, we're going to use that angle to solve for missing side measurements. Now, the 3 trig ratios are sine, cosine, and tangent. You're going to want to know those. Those are going to become your friends. So we're going to do some practice on how to actually set up trigonometric functions, identify the 3 different ratios, and then solve problems using them. So let's go on to our next slide. You can stop at any point if you need to pause and catch up, but let's go ahead and move on for the sake of time. And keep in mind, guys, this will be posted on Edmodo as well, so you can always go back and watch the video again and have another look through everything, and you'll be in good shape. So what we just did, the sine of the angle being the opposite over the hypotenuse, the opposite over the hypotenuse, whenever you put those two lengths into a fraction together, we give it a fancy name. We call it the sine. Okay, so what I just did on that slide before was actually the sine, okay, the sine of angle B. You didn't know that because I hadn't given it a fancy name yet. So that's the sine of angle B. And over here, I did the sine of angle E. Okay, because I did the opposite divided by the hypotenuse. So whenever we put these into specific arrangements, we have a fancy name for it. And your job is going to be to remember that fancy name for each of the three different fractions. And these are those fractions. We call it the sign whenever we make a fraction out of the opposite over the hypotenuse. We call it the cosine whenever we compare the adjacent to the hypotenuse. And we call it the tangent whenever we make a fraction out of the opposite and the adjacent. All of these are determined by the reference angle. So our reference angle in this example is angle A, and I've drawn a nice little smiley face. So our smiley dude is actually the one we're seeing everything through his eyes. Okay, so the first thing we want to do is identify, when we're setting these up, what is the opposite side? Everything's about angle A in this scenario. So remember, the first thing we're going to do is figure out which one's the hypotenuse. And in this case, it's going to be C. We now figure out which one do we have to travel across to get to. And that's going to be A. That'll be our opposite. Okay, and that leaves us only side B for the adjacent side. So HOA, those are the three. We always want to identify those first. And then we're going to create those three fractions. Now there is a mnemonic device that you can use, a little phrase you can remember, SOHCAHTOA. You may have even heard that before. And it's just a little way for us to remember that the sine is equal to the opposite over the hypotenuse. The cosine is equal to the adjacent over the hypotenuse. And the tangent is equal to the opposite over the adjacent. And then here it is written again, but with the actual fractions sort of more visual so that you can see them. You can write this either way. And there's a little phrase that I'll say, and you can write this down if you want to, but it's some old horse came a-hoppin' through our alley. Some old horse came a-hoppin' through our alley. Now that sounds like it was written in like 1921, and it might just be that old, but that is actually the phrase that was around when I was a kid, and there are a couple other ones. It's actually kind of a fun game to see if you can figure out one for yourself, one that maybe fits with your life, you know, referencing things that you know, but anything that'll help you remember which fractions go together is going to be huge. So you want to make sure you're writing this down. Let's go ahead and do a little bit of practice. I'm going to demonstrate one, and then I'm going to give you time to demonstrate another one. So the skill you want to learn here with this first example is to be able to write the trigonometric ratios or fractions. That's all a ratio is a rational expression, which means it can be divided as a fraction for a given reference angle. So our reference angle in this problem is T. Okay, so I'm going to switch colors just for fun. So T is our reference angle. T is where we're seeing everything from. So the first thing we want to do is, from the perspective of angle T, we want to identify the hypotenuse, the opposite, and the adjacent. So the hypotenuse first, that's going to be the one that is across from our 90-degree angle. The opposite is going to be across from our angle, the reference angle, and the adjacent one is the only one left over. So we just want to then go through and put fractions together using the numbers that were given here as our sides. The sine of T is the fraction, that's the fancy name for the fraction that is the opposite divided by the hypotenuse. So the opposite is 8 and the hypotenuse is 17. So that is the sine of angle T, 8 over 17. Now the cosine of angle T is the fraction that is represented, I'm going to have to go down here a little bit. That is represented by the adjacent, okay, the side adjacent to T, divided by the hypotenuse. So that's going to be 15 over 17. And then the last one here is the tangent. And that one's going to be the opposite over the adjacent, which is going to be 8 divided by 15. So when you're asked to find the trigonometric ratios, all you have to do is create the fractions. Okay, easy peasy. Now I'm going to go to the next one, which is an example for you to work out. So this one is your turn to practice. You can go ahead and pause the video now and give yourselves about 2 minutes to write the three tangent ratios. Actually write the sine, cosine, and tangent ratios for angle B. So figure out first what your reference angle is, identify hypotenuse, opposite, and adjacent, and then write out your fractions. Okay? Okay, hopefully you're now unpausing the video and you have gone through and written all of these out. We'll work them out together now. But let's go through for angle B, and let's remember that we are first marking our reference angle. That's the first thing you want to do every time. And then we want to identify the locations. Notice that B's in a little different spot now than the last couple problems we've done. So the hypotenuse is easy. That's across from the right angle. The opposite is the one we have to travel across to get to. So this is our opposite. And then we have adjacent is the only one left over. Notice how I leave that adjacent for last every single time. It's always the one that's left over. Okay, now the sine of angle B is going to be opposite over hypotenuse, okay, which turns out to be 56 divided by 65. Okay, and I don't think you can reduce that, so we are okay to leave it just as it is. The cosine of angle B equals the adjacent over the hypotenuse. Remember, came a-hoppin'. Came a-hoppin'. So adjacent is 33, and the hypotenuse is 65. Again, I don't think we can reduce. Okay, and then we're just left with the tangent. And the tangent is angle B, okay, and that's going to be opposite over adjacent, which is going to be 56 divided by 33. Now, hopefully you're starting to see a little pattern here that we have the trig function, and then the angle, and then two side lengths. It's always three pieces of information, one angle and two side lengths. We're going to be able to use this same type of equation, and we're going to know two of these pieces of information, and we're going to be able to solve for the one that's missing. That's the next step we're going to move to. So I'm going to go on to the next example. I'm going to work this one out for you. And the skill you're going to learn here is to be able to use a trigonometric ratio to solve for a missing side length. Okay, we are given a right triangle, and we're going to go ahead and mark that as right. We do know that that's a right angle. Okay, so that's a right angle. This is a 32-degree angle, and it's the only angle we're given. Now, we could find angle B, but we don't need to. We can just work with this angle as our reference angle. So what do? Once we identify the reference angle, we then figure out which one is the hypotenuse, which side is the opposite, and which side is the adjacent. Now, the trick that I'm going to show you is that you want to look for which side do you have and which side do you need. You have the adjacent and you need the opposite. The hypotenuse is not given and we're not being asked to find it, so we don't need a trig ratio that involves the hypotenuse. So I'm going to write it up here, SOHCAHTOA. Okay, and I'm going to look which of these does not involve the H. And hopefully you're saying, Miss Kreider, it's the tangent, because that's the one we're going to use. We have the tangent ratio involving the side that we need and the side that we have. So we're going to set it up like this. The tangent of our 32-degree angle equals the opposite, okay, which is x, divided by the adjacent, which is 35. Now we've got an equation, and this just becomes all about algebra. So the first thing I ever do whenever I have a tangent and I know the angle, so sine of an angle, cosine of an angle, or tangent of an angle, if I have the number for the angle measurement, then I'm going to go ahead and solve using the, oops, there it is, solve the measurement of that. So we're going to do tangent of 32, and we're just going to hit our equals button. And it equals 0.62486, and I'll round that up to 0.6249. So let's go back over here, and we know that this equals 0.6249. And we just got that from the calculator, and 0.6249 equals x over 35. Now, if I were to, there are a couple ways you can approach this. You can just multiply both sides by 35, or you can go ahead and show this as a fraction being divided by 1, and then you can, sorry, I'm going to make this just a little bit bigger now. the fraction being divided by 1, and then you can cross multiply. So when you cross multiply, you would just get x times 1 equals 35 times 0.6249. Okay, and then x is going to equal 35 times 0.6249. And bear with me while I go back to my calculator. So times 35. And we get about 21.87. You're going to get lots of decimal answers, and that is just fine. Okay, 21.87. Okay, now it's time for you to practice this on your own. So it's your turn to find a side length. You're going to solve for x using this problem. I'll pause for a moment, and then we'll go ahead and work that out. Okay, time to work this one out. Now, this one again involves that 31-degree angle. Okay, so that's our reference angle. We first identify how each of the sides are labeled according to that being the reference angle, starting with our hypotenuse. We have x as our opposite, and 22 is our adjacent. Okay, labeling is key. Now that we've labeled it, we have to determine which trigonometric ratio we're going to choose. Okay, so I know that I have the adjacent and I need the opposite. Once again, I'm going to use the tangent function. So I will write my equation. The tangent of 31 degrees equals the opposite, which is x, divided by the adjacent, which is 22. Okay, so I'm going to convert the tangent of 31 degrees to a value using my calculator. So tangent of 31 equals 0.6008. Okay, let's go back. Okay, so we've got that as 0.6008 equals x over 22, and we just want x. So as we saw the last time where we cross multiplied, this time I'm just going to do the algebraic method. I'm just going to multiply both sides by 22. Okay, 22. Sorry about these numbers. I know they look kind of funky. So we're going to do 22 times 0.6008. These will cancel, leaving us with x equals 22 times 0.6008. And we'll come on over to our calculator and multiply this times 22. Okay, and we get about 13.22. So 13.22 is our answer there. Okay. All right, let's go to the next example. For this one, we are going to be asked to solve for the angle measure. Normally, when we have two sides of a right triangle, our instinct is to find the third side using the Pythagorean theorem. But one of the things that's powerful about trigonometry is that we can mix it up. If we have one side and one angle, we can find another side without Pythagorean theorem. If we have two sides but we want an angle, we can use trig, and that's really the only way we're going to be able to solve for that missing angle measure. So this one's a little bit different though, so I want you to pay close attention to this example. And anything we don't finish in class, by the way, that's okay. This video will be on Edmodo. You can finish the guided practice there, watching the examples being worked out, and then use that to guide you as you do your worksheet. So for this one, we want to solve for the measure of angle H. That means that angle H is going to be our reference angle. So remember, that's key. Angle H is our reference angle. So what's the first thing we do when we identify the reference angle? We identify the labels for each of the sides. So the hypotenuse always is first, okay, because that's the easiest. The opposite is going to be next because that's the second easiest, and that leaves us with adjacent. So I now recognize that I have a need to set up an equation involving angle H and the side that is adjacent and the side that is the hypotenuse. So using my SOHCAHTOA mnemonic device, SO is sine opposite over hypotenuse, CA, cosine adjacent over hypotenuse, TOA tangent opposite over adjacent. And this one looks like it's going to be cosine, okay, CAH, because the A and the H together is what we're looking for. So I'm going to set up my equation. The cosine of angle H equals A over H, which is 6 over 10. Now, we can reduce that. If we wanted to, we could reduce it down to a decimal. We could reduce it to a fraction, but we don't need to be able to do in the calculator what we need to do. I want you to notice something right here. We can't just put that in the calculator because the variable, the thing that we don't know, is actually connected to our trig function. And we're getting into some dangerous territory here. This is where a lot of students make big mistakes. There's only one way to extract that variable, to undo the cosine, and that is to inverse it. Okay, just like we undo multiplication with division and we undo subtraction with addition, we're going to undo cosine with inverse cosine. And it looks like this, okay? Cosine to the -1 is what the inverse cosine looks like. Okay, so we're going to inverse both things. Cosine of angle H equals cosine, and remember what we do to one side, we have to do to the other. And I'm writing it out like this for a particular reason, because this is actually what you're going to put in your calculator, and you'll never actually do what's on the left. That's just to show you what's going on. Because when we do this, these two things cancel. Okay, the cosine of the -1 and the cosine cancel each other out, leaving us just angle H over here. But what's key is that in the calculator, we're going to do the inverse cosine of 6 over 10. And that turns out to be pretty easy. So we're going to clear. And this is where we have to use see the little -1 in the gray there on the cosine? We have to use the second key to call that up. And notice on this calculator, it turns it to a cosine. That just means arc cosine. It's another fancy way of saying inverse cosine. And they show you right there in the bar that it's -1. So the arc cosine of, and I'm just going to do it like a fraction. How about that? 6 divided by 10, except I've just lost my division button. So we are going to wing it, and I'm actually going to do 6 divided by 10 is 0.6. We're just going to put it in as a decimal. Okay, equals, and I get 53.13 as my answer. So I actually know, without a shadow of a doubt, that my answer is 53.13. And I hope I'm remembering this right from that other screen. 53.13 degrees. And that's it. It's really not that hard. But it's that same pattern. Identify your reference angle, label the parts, figure out which trig ratio you need, and then set up your equation and solve. The key is, when do I use the inverse and when do I use the regular? Regular is to find a side, inverse is to find an angle. Okay, let's have you do a practice on your own. Go ahead and pause the video now. Okay, you can unpause the video, and now we're going to go ahead and solve for the measure of angle N, and we're going to walk through that process again. You are going to identify your reference angle. It's angle N because that's the one we're solving for. The hypotenuse first, the opposite, and the adjacent. We don't need the adjacent, so we're going to figure out which trig ratio uses opposite and hypotenuse. That one turns out to be sine. So we're going to write the sine of angle N equals opposite, which is 15, over 20. Okay, now I already know that 15 over 20 is going to reduce to 0.75, so I'm just going to rewrite it like that. The sine of angle N equals 0.75. Now, you don't have to write that whole inverse thing out in full the way I did. You could just do this. Angle N equals the inverse of sine of 0.75. And that's it. And then you're ready to put that in your calculator and then solve for your angle measure. So we want to inverse sine 0.75. Okay, clear. We're in a second sine 0.75 equals. Okay, we've got an angle measure of about 48.59. Okay, so 48.59. And we are good to go on that problem. 48.59. Okay, the last question is for you to do on your own, and this is a real world application. So go ahead and read this over. I'm going to pause the video. You pause the video. And then when you come back, we'll work it out together. Okay, so hopefully you've had a few minutes to try to work this out on your own. We're going to change up the color to blue just for fun. Now, I see a picture here, and I don't really actually see a triangle. However, I know immediately that I can kind of draw a vertical line right there, and that 21 feet is going to be the same as that height. So I do actually see a triangle, and it's a shortcut triangle. It's a 30, 60, 90 because I see that 30-degree angle. So right away I know I'm going to use shortcuts to answer this one. So if I know this is 30 degrees and this is 90, then that means this 21 is my short leg. And they are asking me, and let's go through the problem, an escalator lifts people to the second floor of a building. I'm assuming this is floor 1 and this is floor 2. Okay, so 21 feet above the first floor. So 21 feet is the distance between the floors. The escalator rises at a 30-degree angle. Okay, that's our angle of elevation. To the nearest foot, how far does a person actually travel from the bottom to the top of the escalator? So they're really going from here to here along this path. So what we really want is the hypotenuse of this triangle. And since this is the short leg, if you remember with our 30, 60, 90 shortcut rules, if we know the short leg, the hypotenuse is just equal to 2 times the short leg. So in this case, our hypotenuse is equal to 2 times 21, which is 42. Okay, so you are good to go. This will be on Edmodo. You can watch it again if you need to, or go zoom into specific parts in order to figure this out. Hopefully this was helpful, and we'll see you again tomorrow.